own time, and they can be able to understand what is happening.
Yeah.
So without wasting any time, I will request that you mute your mic so that at
It's
least
okay.
there is no echo, and then we can start off. So for this, for today's class, we are still continuing with the concept of software testing, and we are trying to understand some of the concepts which are normally put across when we are talking about software testing, activities which take place during software testing. And in this, we are trying to, or by the end of this class, we will be able to understand the difference between audit and inspection. We will also try to understand the difference between testing and debugging a software. We will also try to understand testing myths or to demystify some of the ideas which are normally put across when you're talking about software testing. Then we will also want to achieve the goal of
Naona
understanding
kaa network.
what is testing and the ISO standards which are normally used in testing. Then we will understand Square. We will also understand what is testing types, the different testing methods, levels of testing, and then testing documentation, as well as estimation techniques, which can be used when you want to create a testing scenario. So that is what we will try to achieve by the end of this course, or by the end of today's class. We will try to understand all these things. So one thing we want to understand, when we are talking about auditing, what exactly do we mean? So by definition, auditing is going to be the systematic process which is normally used to determine how the actual testing process is going to be conducted within an organization or a team. Because the moment you start the testing process, you need to first of all check whether that testing process is going to work. So you need to audit the testing process, or you need to check. That is why we are calling it a systematic process, to determine how the actual testing process is going to be conducted within that organization. So it is going to be an independent process, which we are calling here, which is going to be involved in the testing itself, or in the testing of the software. So it is an independent process, or it is a process that is going to be carried out before you start the actual testing process. And this audit process can actually include what we are calling the legal compliance. We can also talk of an internal audit and also a system audit. So you want to see if you are complying with the legal provisions which have been given. You also want to make sure that internally all your processes are working as expected, and you also want to ensure that the system which you are going to use to test your software is also in according to the standards. So that is what we mean by an audit. But then we go to the other concept, which we call inspection. And inspection is going to be now the formal technique which involves the review. Either you are doing the review formally or informally, so that you can be able to identify any gap or any error. So that is what is meant by an inspection, the formal technique which will include the review of the software. So you are doing a walkthrough, or you are doing a code checking, or you are doing a functional checking, just to see, is there any error in the way this software is supposed to work? Is there a gap in terms of the expected objectives of the software which it has not achieved? So those are what we call inspections. And these ones we are saying that can be done in terms of the software requirements, also in terms of the software design, also in terms of the code which is being examined. So you go through the code to check whether they are within the required standards, they are achieving the required objectives, and whether they have any fault. So you're trying to detect if there is any fault. You are also trying to check whether there are violations in terms of the development standards and any other problem that can be identified when you are doing an inspection. So an audit is going to be carried out before you are doing the actual testing. During the actual testing, then that is when we call it an inspection process. So that is the difference between those two terms. Then we come to another concept here, which we call testing and debugging. So when you are doing testing, what are you actually doing? Because you might confuse testing with an inspection. Testing now, it is the identification. So here you are trying to detect. So once you detect, then you need to actually test so that you can identify. So testing is the identification of either an error, a bug, or a defect in the software without correcting it. So the first thing you will start with is an audit. Once you have audited your process of testing, then you come to inspection. And here you are just identifying. Then after inspecting, you will be testing, that is identify any error, any bug, any defect in the software without correcting it. So once you have identified, because when you detect, you are not sure what it is. But when you identify, you are sure that that is a bug, that is an error, or it is an defect. And here, once you have identified, then you are not doing any kind of correction. After identifying, then you go to the step of debugging. So debugging, it will involve identifying. So debugging will involve testing. Then you isolate. You isolate what the problem is, where the problem is, and then you fix that problem or a bug. So debugging will involve the process of testing as well as correcting or fixing that problem that it is, or that problem which has been identified within your system or your software. Developers who code the software will conduct debugging upon encountering an error in the code. And so we normally say debugging is part of white box or unit testing. That is something we will check as we continue during this class. Then, after understanding what we call auditing, then we have understood what we are calling inspection. We have understood what is testing, and now we have understood debugging. Then, what are the stories which are normally given? These are the ones we are calling myths. The stories which are normally given in regard to testing, or stories which may not be true when you are talking about testing. These stories include something like testing is too expensive. So people normally say testing is expensive, but in reality, testing can be cheaper than implementing the software, then putting it into operation, and then you come and encounter a problem later. That will be more expensive to stop operations or to stop things you are doing so that you can correct the error. Because when the system is in operation, then it means organizations are depending on this system. And when it is working, it means that this system is going to disable or is going to interrupt operations in the organization for you to be able to correct that error or to debug that system when it is in operation. Now, that process is going to be more expensive than if you had done testing before you operationalized the software. Another myth is that testing is time consuming. People may say that when you are testing, it takes a lot of time. But in reality, during the software development lifecycle stages, testing is never time-consuming process. Because like we said previously, testing normally begins from the moment you have collected your requirements. You have to check and confirm that these requirements are right. Then after that, you go to testing the design. Then after that, you will go to test the code itself. And the testing process continues together with the development process until you have your final product. So testing will not be time consuming if you followed that process of ensuring that in each stage of the SDLC, you normally test it. Another myth is that testing cannot be started if the product is not fully developed. Just like we have said, testing will begin from the moment you are collecting your requirements. So when you collect your requirements or when you collect requirements from the customer or the user, you will have to test these requirements. You will have to check them against operation standard and also confirm them with the user so that when they tell you that these are the actual requirements that you have for your software, then you can continue with development. Then it will continue through the design of the system, through the coding of the system, until the system is actually fully developed. So when you are testing a system which is fully developed, that is always at the highest level or at the user level where they are actually testing whether they accept the system or not. So system testing will depend on the method that you are using for development and will also depend on whether you are testing from the requirements themselves. Another myth is that complete testing is possible. Reality is that it becomes an issue when the client thinks that the complete testing is possible. Reality is that testing is not possible. Complete testing is not possible. You only test the system or you test the software against some standards which have been set or against the requirements which had been set initially in terms of what is expected for the software. So that is how software testing is normally done. So that is why we are saying there may be scenarios whereby the software was never executed by the test team or the client during software development lifecycle. And this means that the project has been deployed. So that is why we normally say testing is never complete, or you can never actually perform a complete software testing. It is normally against some standards, and when that has been achieved, or when a test has passed those standards, then we can say that the software is fit for purpose. Another myth is that if the software is tested, then it must be bug-free. So that is a myth due to this reason that any software which has been developed and which has been put into operation, it will always encounter challenges or bugs or errors may be introduced depending on how it is being used and where it is being used. So that is why it is said that no one can say with absolute certainty that a software application is 100% bug-free, even if the tester with a superb testing skills has tested the application. There could be some errors or some bugs which have not been detected since the system has not been put into use under some certain circumstances. That is why the software will never be 100%. Some errors or some bugs are discovered during the operation of the system, and that is why some softwares, you normally hear of a software having a first version, then it is put into operation. After that first version has been used up, or during the operation of the first version, some errors have been discovered or some flaws in the system have been discovered, then a second version will be developed and put into operation so that it takes care of those bugs or those errors which had been discovered have been patched up. So that is why we normally say that the software is not 100% bug free. Another myth is that missed defects are due to testers. It is not a correct approach, or it is not correct to say that testers are to blame for any error or bug that has been discovered in the system. This is because testing will be constrained to time, cost, and requirements. And these three things keep on changing depending on where the software is being used or the application area of that software. So that is why it is very impossible to completely say that these software or the testers were not exhaustively able to test the system. Software testers will test this software depending on the requirements which are put across at that moment, depending on the time that they have been given and depending on the cost constraint of that system. So that is why you cannot blame the testers. Another myth is that testers should be responsible for the quality of the product. Now, that is a misinterpretation of the concept that testers will conclusively go through the system and be able to get out all the errors. Testers are responsible for identification of bugs to the stakeholders, and then it is their decision whether they will fix the system or not. Because a tester may identify a challenge in the system or in the software, and once they have identified, it is the responsibility of the other stakeholders, the developers and owners or customers to this system, to be able to tell whether they are going to fix that bug or not. So releasing the software at the time when at that time is a lot of pressure on the testers because they will be blamed for any error. But this error should be blamed by to all the stakeholders, because the development process doesn't involve only the testers. It will involve the owners of the software, the project managers, the coders, the implementers, and so many other stakeholders in the development process. Then another myth is that test automation should be used wherever it is possible to reduce or to reduce on the time that is consumed. As much as that is true, that test automation will reduce the time that is possible to test automation can also be changed, because test automation is going to be within some limited testing boundaries. And these testing boundaries may not be able to cover all the test scenarios of that software. So it is very important that the software automation test process can be used, yes, to reduce the time, and then you also include some manual testing processes so that whatever had not been covered by the test automation can be covered by the human aspect of working through the system to be able to tell that it is working as expected. Another myth is that anyone can test a software application. People outside the IT industry will think that they are able to test the software and testing is not a creative job. But when we look at this in reality, people outside IT are what we call novice users. They just use the system for the need they have. But a software tester will test the software throughout or across the different needs of different users. That is why in different alternative scenarios, the software may crash because if it was a user outside the IT industry had not tested that area or that scenario. For example, you could be talking of an application for ordering. Now, people who are ordering maybe and paying via M-Pesa, they might feel that the system is working perfectly until somebody tries to test this system by use of a credit card, then it crashes. So it is the software tester who is in the IT industry who can be able to test the system by thinking through these alternative scenarios where the system can be used. So they will test across different alternative scenarios as compared to just novice users who are testing through one test scenario. Another myth is that a tester's task is only to find bugs. So finding bugs is one of the objectives of a software tester. But a software tester or a developer will be responsible for checking for bugs and also understanding the overall workings of the software. So apart from just checking for errors and fixing them, a software tester will also try to understand the overall workings of the software, what the dependencies are, what else does the software require for it to work efficiently, and also performance of the software. It may be able to work, but its performance level could be low. So it is the work of the software tester to not only find bugs, but also to understand the overall workings of the software, as well as what are the other dependencies which are required for the software to work as expected. So those are the medical ideas which are put across in regard to the software testing process itself and the myths which are normally given, but we have been able to demystify them. The other thing we want to understand is the software testing itself and ISO standards. So ISO is the body that comes up with the standards used in different areas of IT. So it is always called the International Standards Organization. And in software testing, there are standards which have been developed. So the standards we are going to look at, we are going to look at them in regard to quality assurance and testing. So one of the standards is what we call the ISO IEC 9126. And this standard deals with the aspects of software quality. And when it is looking at software quality, there is this diagram which explains that concept. So it will look at the quality model, it will look at the external metrics. So it looks at the quality model, the external metrics, the internal metrics of the software, and quality in use metrics. So let me expand this diagram a little bit so that you may be able to see it. So when we are looking at these quality ISO standards, I hope this diagram is now clearly visible. I will reduce it after explaining it. So under this standard, we are looking at several quality factors. So according to here, there is the quality model, and the quality model is the one we are calling the quality factors. So quality factors will include one, functionality, 2, reliability, 3, efficiency, 4, maintainability, 5, portability, and 6 is usability. When we are talking about functionality, what exactly do we mean? Functionality deals with those aspects of the software whereby it is able to function as expected. So when we are looking at aspects of functionality, we are looking at things as suitability, accuracy, security, interoperability, and compliance. So by looking at suitability, suitability looks at issues to do with how is it able to work within the environment it is prepared for. So here we are looking at user requirements. Have you been able to meet the user requirements? Is the system suitable in solving those requirements the user had given? And in understanding the user requirements is where we are coming down to accuracy. Is the system able to accurately give the results it is expected to give? Is the system secure enough to protect in terms of confidentiality, integrity, and availability? So when we are looking at security, we are looking at those three factors. That is confidentiality, that information within this system is only accessible to those who are meant to access it. When we are looking at integrity, is that information within the system cannot be changed just by anybody, or the information that is within the system remains as it is expected to remain. And then availability is that the system can be accessed whenever it is needed. Then we come to interoperability. This system is going to work together with other systems, be them be human beings, be they be other automated systems. So is it able to interoperate, or is it able to exchange data with them? Is it able to give them feedback as expected, and so on? So when we are talking about interoperability, is that aspect of working together. Is it able to work together with other systems? Then there is the aspect of compliance. Every system is going to work within some set standards. Is it able to comply to those standards? That is what we mean. Then we look at reliability. When we are looking at reliability, we are looking at things to do with maturity, fault tolerance, recoverability, and compliance. When we talk about reliability, we are looking at whether this system is able to work even under extreme or under attacks. That is why we talk about maturity. When we are talking about maturity, is that level of operation of the system whereby it is able to deliver as expected. That is one of the factors. So Kevin says that you'll not be able to finish the class. That is okay, because the class is being recorded, so you can be able to follow the presentation later when we provide it online. So fault tolerance is the aspect of the system to be able to work even when there is a fault. Like we had described what a fault is. A fault is an error that has occurred, but the system is able to overcome that error and continue to work as expected, even when there is that error, which is causing some problems. So fault tolerance, imagine a scenario whereby there has been a network disconnection due to power. Is the system fault tolerant enough to be able to redirect users to another server somewhere where they may be able to continue working as the power issue is being corrected? Recoverability is the aspect whereby if there is a system crash, you can be able to recover the system, you can be able to recover the data that was within the system as expected, and the system continues to work as if there was no crash which had occurred. And then there is also compliance, whereby in terms of reliability is that the system is compliant to the set standards of maybe fault tolerance and recoverability or mirroring. When we are talking about fault tolerance, it could also be an aspect of mirroring a server. Imagine a server which you are trying to access and it crashes. Are you able to be redirected to another mirror server and continue operating as if there was no crash at all? Then we come to the other factor of quality, which we normally call efficiency. Now, when we are talking about efficiency, we are looking at things to do with time behavior, resource behavior, and also compliance. So when we are looking at time behavior, is how long does it take for this system to be able to give you the results that you are looking for? Or how efficient is the system in terms of time? And time will go together with performance. If you request for a report, how long does it take for this report to be delivered to you in terms of either microseconds or whatever it is? And here we test it in terms of the turnaround time. So it is normally called the turnaround time because it is the time taken for the request to be sent to the server and for the feedback to be given back to the user. For example, if we take an example of Google, if you searched something on Google, there is that time which is normally taken for the request to go to Google servers and then the response to be given to you. Normally, it is 16 milliseconds. That is a very short time. So we can talk about time behavior or time performance as for Google to be 16 milliseconds. Then resource behavior, how much resource does this software take up in terms of the processor time, in terms of the memory which it requires for it to operate. So when we are looking at resource behavior, we are looking at the hardware resources which it requires to consume for it to give the user the required result they are looking for. So again, if we go to the example of Google, how much memory does the Google browser take? How much processing time or processor capability does it consume for it to be able to give the results it requires to give you? And then compliance is those resources, are those resources efficiently used in terms of their compliance to software requirements? Then we go to maintainability. When we are talking about maintainability, is that aspect of the system to be easily maintained and to be easily correctable. And we look at them in terms of analyzability, changeability, stability, testability, as well as compliance. So when we are looking at analyzability, if there was a problem, are you able to analyze it with ease? Are you able to determine where the problem is quickly and without any challenges? When we are talking about changeability, are you able to change from one mode of operation to another? Are you able to update the system, or are you able to correct the problem and update the system without any kind of a challenge? Because when we are talking about maintenance, is that continuous appraisal, continuous correction of any system during its operation. So are you able to make those changes without any problems or with ease? Stability is that aspect of the system remaining able to serve the consumer without any problems, or if there was some maintenance being carried out, the user will not feel any challenge. The user will not see any kind of disturbance during their working with the system, as much as there are updates being carried out during the system operation. Testability is, are you able to test the operation of the system with ease? And then compliance, are you complying to the set standards in terms of the system operation? Then we go to portability. Portability comes in the aspect whereby we are looking at systems which are able to work at a server environment, a desktop environment, and then a mobile environment. Are you able to carry this system across those different environments? That is what we mean by portability. And we are looking at it in terms of adaptability, installability, coexistence, re replaceability, and compliance. So adaptability, when we are creating browsers or these web-based systems, we are creating them so that you can open them in a server environment, in a desktop environment, and in a mobile environment. So this system can work in different environments without adjusting anything. You can open it, if it is your email, you can open it, you can open that browser in your mobile phone, you can open it in your laptop, you can open it in a server somewhere, and you don't need to make any adjustment. The same with installability. You can install it on any environment or any platform, be it your laptop, be it your desktop machine, be it your mobile phone. Coexistence is that it is able to work in with other. Coexistence is closely related to interoperability. It is able to exchange information, it is able to exchange data, it is able to communicate with other systems within that platform we are looking at. Then replaceability, you are able to replace this system or to update it accordingly without any challenges. And then compliance, is it complying to the set standards as expected? Then we look at usability, and usability, we look at it in terms of understandability, learnability, operability, attractiveness, and compliance. So understandability, you as a user, are you able to understand how the system operates without any challenge? Are you able to learn through the system in terms of navigation, in terms of its operation, in terms of working different buttons and all of that? Are you able to learn it as you use it? Operability, are you able to operate the system without any challenge, without asking for any help? Attractiveness, is the system attractive? And here we are looking at this system in terms of human-computer interactivity. Are you able to be attracted to how the system is oriented, the appearance of the system, the color schemes, the organization of different buttons on the screen? Are you able to navigate through them in an attractive manner? And then compliance, is it complying to the set standards of human-computer interaction? So those are the quality factors we are looking at in terms of quality standards. So they are 6 of them. Please note them and understand them properly. Functionality, reliability, efficiency, maintainability, portability, and usability. So let us continue from there, and we look at the ISO 9241 part 2 of those standards. So how do you look at these standards in a brief, or the standard that is normally set to give a framework of how these usability components are going to work together and how they are related to one another? So this is the diagram which is able to explain this to us. So let me expand it so that we can discuss it quickly. So when we are looking at those different standards or those different quality factors, we look at them in terms of the user and the objectives that the user has towards that software system. That is why the user will be performing different tasks, and these tasks are performed with an equipment. And here we are talking maybe of a keyboard and a mouse. And then this equipment is working in a certain environment, maybe a desktop environment, a mobile environment, or a server environment. So that is where we are talking about the context of use. And this context of use is where the product is normally put across. So we are talking of a product that is a software. So usability will extend to the effectiveness of the system, the efficiency of the system, and the satisfaction of the user. So that is how we can be able to measure the usability of the system. And that usability of the system will be dependent on these other factors. The usability of the system will be measured in terms of functionality, in terms of reliability, in terms of usability, in terms of efficiency, in terms of maintainability, and in terms of portability. So when we are looking at usability measures, they will go back to those quality factors we have already looked at. And that is normally the objective of having quality factors measured against the context of use of that software application. So that is the diagram which summarizes those standards. Then there are other standards we normally talk about, which we refer to as square. Now, square are standards based on ISO IEC 25000 standards. These ones were developed in 2005, and they are normally guidelines for software product requirements and evaluation. That is why we call it SQUARE. Software quality, software product quality, requirements and evaluation, which is abbreviated as SQUARE. Now, these standards helps in organizing and enhancing the process related to the quality requirements. Like we have said, testing will normally start from requirements evaluation, or once the user has given their requirements, they will be evaluated to ensure that they are the correct requirements. Because one thing you need to note that is that a user will give the business requirements. It is the work of a software engineer, it is the work of a system analyst to translate these business requirements into system specifications, which are now the quality requirements. So these standards are supposed to be able to ensure that these requirements are, are up to the required standards. And they include the quality management division, they include the quality management division, the quality model division, the quality measurement division, quality requirements division, and the quality evaluation division. So, how do we go about them? They are just general guides, and they are supposed to ensure that the specification, the planning, and measurement, as well as evaluation process goes up to the standards. And when we are talking about standards, is what the user expects. So when we start with the first one, the quality management division is supposed to look at the requirements and then check them against the standards of the set organization that will come up with the software. The quality model division will look at those requirements and then gauge them against the set standards for modeling a software. Then quality measurement division will look at the development team and be able to check it against the software development standards of the methodology that is being followed. Then the requirements division will test the software that has been developed against the requirements which had been given by the user. and then evaluation is just the division which looks at the overall performance of the software and evaluates whether it is up to the expected standards. So those are the functions of those different subgroups. Then we look at the ISO IEC 12119 standard. And this one deals with software packages which are being delivered to the client. So it does not deal with the client's requirements or the client's production process. No, its main content will be related to the set of requirements for software packages. So here, this one looks at basically what are the industry standards when we need to package this software. For example, we need to package this browser as a desktop application and also as a mobile application. So they will look at the standards, the industry standards that are available and package that software according to those standards. Also, they will package the software in regard to the instructions for testing the delivered software packaged against the requirements. So those are the main standards which are normally followed, which I want you to look at them at a later time and familiarize yourself with them. Then let us go to the different testing types. We normally have two types of testing. One of them is manual testing, and the other one is the automation testing. When we are talking about software testing, which is manual, we are looking at it without using any automated tool or without using any other software, because automation testing is scripted, or there are guidelines or instruction on how the software is going to be carried out. But in manual testing, it is the type of testing whereby the whole process is done manually, whereby the tester will take over the role of an end user and test it according to the standards that have been given, the ones we have looked at there previously. And what they are trying to do is to check if there is any unexpected behavior or if there is any bug or error. So they are checking for any unexpected behavior or any bug or error. So when you are doing manual testing, it will also go through the unit testing stage, the integration testing stage, the system testing stage, and acceptance testing stage. As much as it is being done manually, but it will go through those different levels. So the testers will use a test plan like we had seen. They will create different test cases. Then they will test the software to check the completeness or to ensure that the test is complete in itself. Then there is the automated testing, whereby you create a test script, then you execute the test, and then the combination of a test script and a test execution is what we normally refer to as the automated testing or test automation, whereby scripts or the tester will write a script and uses another software to test the current software which is being tested. So what it basically means is that the automated process is just an automation of the manual process. So instead of doing it manually, you are going to do it according to a script, and then you can rerun the process over and over until you are sure that you have the right software. So testing will be done several times, and the goal of automating the test is to ensure that you can do it severally and it takes less time. That is basically the whole concept of automating the testing process. So when do you automate? If the software is large or the test is going to be carried out to several softwares, or the requirements are not changing frequently, or accessing the application for load and performance with many virtual users, or when you have a stable software with respect to manual testing, and when there is time to automate the process. So that is how you can carry out the automated. So we have two types of testing. One is the manual testing, the other one is automated testing. Now, these are examples of the tools that you can use for automation testing. You can look at them in your free time. So let us look at the different methods of testing. When you are doing testing, you can either perform black box testing. And when we are talking about black box testing, is when you are testing the software without having any knowledge of the interior workings of the system. That is why it is called black, because you are not checking what is inside the software or what are the workings behind what you are doing outside. So when you are performing the black box testing, the tester will interact with the system's user interface by providing inputs and examining outputs without knowing how and where the inputs are worked upon. So you are not understanding the algorithms, you are not understanding the coding behind, but you are just interested with the output, how it is coming, and when it is coming. So the advantage of this is that it is suited for large code segments. The code access is not required. It clearly separates users' perspective from the developer's perspective, and large number of moderately skilled testers can test the application without any knowledge of the programming language or the operating system. In terms of disadvantages, it is that it is limited to a number of test scenarios because you are not exposed to the inner workings of the system. It is inefficient due to the fact that the tester can only have a limited knowledge about the application, and it has a blind coverage since the tester cannot understand or cannot target a specific code segment to check whether there is an error. Then we come to white box testing. And when we are talking about white box testing, it is another type whereby the tester has a detailed understanding of the internal logic and structure of the code that is implementing the software they are testing. So in order to perform white box testing, the tester needs to process the knowledge of the internal working of the code. They need to understand the programming language, the programming standards, and they need to understand the logic of the code so that they can be able to test the code. So an advantage is that the software tester has knowledge of the code, and it becomes very easy to find out which type of data can help in testing the application properly. It also helps in optimizing the code, and extra lines of code can be removed, which can bring in other defects. And due to testers' knowledge about the code, maximum coverage is attained during the test scenario writing. But in terms of disadvantages, one of the disadvantages is that due to the fact that a skilled tester is needed to perform the white box testing, the cost is going to increase. And sometimes it is impossible to look into every corner of the code in order to identify hidden errors that can create problems, as many parts will go untested. Also, it is very difficult to maintain a white box testing as the use of specialized tools like code analyzers and debugging tools are required. And then we have the in-between method, which we call the gray box testing, whereby in gray box testing, you are going to combine both white box and black box testing, whereby the tester needs to have an understanding of the code implementation as well as what are the inputs and outputs expected from that system. That is why it is called gray box, because the tester will only test the user interface, but the tester will also need to understand or will need to access the design documents and the database so that they can have an understanding of the logic of the software. So in terms of advantages is that it offers combined benefits of both black box and white box testing, and gray box testers do not only rely on the source code, but they also rely on the interface and the functional specifications. So gray box testing also can design excellent test scenarios, which are especially around communication protocols and data type handling. Then the test is done from a viewpoint of the user and not the designer. In terms of disadvantages, we can say that since the access to the source code is not available, the ability to go over the code and test coverage is limited. Also, the test can be redundant if the software designer has already run a test case, and testing every possible input stream is unrealistic because of the time that will be taken. So these three methods of testing can be compared with this table, which I will leave you to look at and try to understand. But then let us continue because I have explained the difference between the three. Let us look at the levels of testing. When we are looking at the levels, we have the functional level and the non-functional level of testing. So at the functional level, we are looking at it in terms of a black box kind of testing, whereby we are looking at has the software achieved the functionality it was created for. So here, the first step we normally perform is to look at what are the functionalities expected or intended for this software application. And then the second step is you create the test data based on the specifications. Then step 3, the output based on the test data and the specification of the application is gotten. And then after that, step 4, you write the test scenarios and execute the test cases. And then in step 5, you are doing a comparison of the actual and expected results based on the executed test cases. And in functional testing, that is where we normally look at unit testing, whereby we are looking at the specific components or specific modules or units of that software, and we are looking on whether they have been able to achieve the functionality for which they have been created. Then we come to integration testing, whereby we are trying to combine these modules or these units, and once we combine them, we try to see if they are functioning correctly together. So that is where integration testing comes in, where we are trying to determine if they function correctly together. And in order to check whether they are functioning correctly together, we do it in terms of bottom-up integration and top-down integration. So bottom-up integration is where we start with unit testing, then you follow up that with a combination of units, which we are calling modules or builds. The other one is where we start with the highest levels of the modules, or we start with the system integrated together, and then we break it down to the specific units. Then we go to system testing, whereby the next level testing after integration. And here we are looking at all the components. Once they have been integrated, the application as a whole is going to be tested rigorously so that to see if it meets the quality standards like we had looked at them. So system testing is important because that is the first step where the system has been tested as a whole and the application is tested thoroughly to verify that it meets the functional and technical specifications. And then the system will be tested in an environment whereby now you can be able to see if it is in the work environment, is it working as expected? And then the system testing will enable in identifying and verifying if the business requirements have been met. Then regression testing, like we had described it, is that level of testing whereby the 3 stages are going to be checked. And if there is any challenge, you go back to unit testing, come back to integration testing and system testing. And you keep on doing that cycle until you are sure that there is no error which is coming up. So system testing is important so that we can minimize the gaps. We can also test the new changes. Then we mitigate the risks and test coverage is increased as well as increase the speed of marketing the product. Then after that, we come to acceptance testing. That is the highest level. And this is the one which will involve the functional testing at the client's perspective. And this one is important because if the system is not accepted, then it will be of no use. So when we are looking at acceptance testing, we are looking at it in order to gauge whether the application is meeting the intended specifications and is able to satisfy the client's requirements. That is the importance of acceptance testing. It is being tested to see if it is meeting the intended specifications and it has been able to satisfy the client requirements. So the quality assurance team will create some set of pre-written scenarios and test cases that will be used to test the application. Then, when we are doing this testing, it is divided into 2 areas. The acceptance testing is divided into alpha testing and beta testing. So when we are talking about alpha testing, it is the first stage which is being done between the developer and the quality assurance team. So that is alpha testing, which is being done at the developer's site. And here it is being done to check for any spelling mistakes, any broken links, cloudy directions, or the application is being tested on machines with the lowest specifications to test the loading times and any latency problems. But when it comes to beta testing, it is performed after you have successfully completed the alpha testing, and it is intended to test the system before it is released to the user. And here it is being tested in a real world scenario. So beta testing is where you have taken the system to the client environment or to an environment which is similar to where the system will be used by the client and check whether it is able to perform as expected. So that is the difference between the beta alpha and beta testing. Then we come to non-functional testing. And here, during non-functional testing, we are trying to check the software from the requirements in terms of performance, security, and the user interface. So non-functional requirements are those requirements which, even if they were not there, the system will still be able to work. So that is where we are looking at things such as performance of the system, security of the system, and the user interface. Is it appealing? Is it attractive to the user? So here, when we are doing performance testing, we are just trying to see, are there any bottlenecks? Are there any performance issues? So in terms of network delay, client-side processing, database transaction processing, load balancing between servers, and data rendering. When we are looking at performance, we're also looking at things like speed, and speed we are looking at response times, data rendering and accessing. We're also looking at capacity, stability. We're also looking at scalability of the system. Kindly, Kevin, may you mute your mic? There has been some kind of noise. We are also looking at the stress levels of the system and load testing. When we are looking at load testing, it is trying to put a lot of load into the system to see if it can be able to manipulate large input data or large number of users so that you can able to test the stress levels of that system. So when you are testing the stress levels of the system, you are taking away the resources which are supposed to be there and see if there was a shutdown and a restart of the network, can the system resume without any challenge? Trying to turn off the database and see, can the system be able to save some data somewhere so that when the database comes back on, are you able to load that data again and continue with operation? You try to run the different processes that consume resources, such as the CPU, the memory, the server, and you see if it is able to respond accordingly. So that is where we are talking about the levels of testing, different stress levels, different environments, and such. And then after trying to test all of those, security, that is in terms of confidentiality, integrity, and authentication, as well as availability in authorization, non-repudiation, software is secure against any known and unknown vulnerabilities. Once you are through with all of those tests, the next thing we go to is test documentation. And when you are documenting, you are documenting things such as the test plan, the test scenario, the test case, and traceability matrix. The test plan is what is the objective of this test? Then how do we go about the test? And how do we compare the results? Then test scenario is creating the environment where you can be able to test the plan. Then the test case is actually executing the tests. And then traceability is that scenario whereby you can be able to repeat that test again and again to see if there is any kind of improvement after you have corrected any error or bug that was discovered during the test case. So that is one of the things you need to do documentation for. And this I will leave for you to look at, and then we can discuss it from there. So when we are talking about tests, those are the kinds of methods we normally use. The estimation techniques, I will leave them to you to look at, and then we will discuss them and after we have given the quiz. So thank you for your time, and I will